Hi, and welcome back to Introductory Algebra. We're in section 3.5, and we're going to be looking at slope today. So slope, in its most basic, is what we would call rise over run. So it's how far up a line goes, or down, versus how far sideways the line goes. So that the rise is up and down, the run is sideways. And so generally speaking, slopes come in four different kinds, and we'll see two of them a bit later, but I want to start by just talking about two of them. A line that goes uphill from left to right, like this one that I have on the board, is going to have a positive slope. If it were to go downhill from left to right, it would have a negative slope. So I want to look at this example that I have on the board. I picked out 2 points that were on this line, and I labeled them, so we have the point 0, 1 and point 3, 5. So the first way that we can find a slope is to actually just basically count out the rise and the run. In this case, I can see that the line is going up, so I'm expecting my slope to end up with a positive value. So let's count. For the run, I start at 0 because that's my x-coordinate, because I'm going sideways. I'm going to count for my x's, and I just go right. 1, 2, 3. And you can see I drew a dotted line there across the bottom, counting over to the side. And then for the rise, I go up 1, 2, 3, 4. And so my rise is 4, my run is 3, and my slope is a positive 4/3. Now, it's just very important to be really careful with signs. Again, if this were going downhill, we would want it to end up being a negative slope instead of a positive slope. So that's one way we can find a slope, but there is a formula that basically does the same thing. Okay, it's going to use some subtraction, and it works nice because then you don't have to have a graph so that you can actually count out all those different values. It's just in some ways easier. In some ways it's a little tricky too, but you'll be okay. If you can subtract and you can divide, you can do this. The hard part will be anything with negatives in it. So let's get a new board and we'll take a look at the formula for finding a slope. All right, so on this board I have an example, or I have the formula for us for finding slope from 2 points. I have an example, and then we'll move on and look at some other things with slope. So given 2 points, x1, y1, and x2, y2, the little numbers here on these points, they're just set it apart as first point, second point. X value in the first point, y value in the first point. That's all those are telling us. So here's the formula. M, because we use M for slope, is equal to y2 minus y1 over x2 minus x1. Now, this should make some sense with what we talked about just a minute ago. Slope is rise over run. Y's are up and down, x's are sideways. So they work on giving us the rise and the run. So we have y2 minus y1 over x2 minus x1. Now, here's my 2 points, 4, -2, and -3, 6. So I'm taking this one as the second point because it's the second one on my board. Turns out it doesn't actually matter which one is the second point. We'll talk about that in here in a second. But I do y2, 6, minus the -2. And then I do the x's, x2, -3, minus 4. And if I do those all in the right order, I get the right answer here. So 6 minus -2, that's like adding 2, so it gives me 8. -3 minus 4 is -7. I end up with a -8 over 7. Now, would it matter if I turned it around and did it the other way? The answer is no. You should still get the same answer. But importantly, the y's are on top, the x's are on the bottom, and the order has to be the same. So since I did 6 minus -2 on the top, I had to do -3 minus 4 on the bottom. Okay, and we're going to get some helpful hints and suggestions here on the next board, along with probably another example. All right, so I mentioned that I was going to have a few helpful hints and suggestions, things to watch out for. First of all, it is rise over run, so the y's are on top and the x's are on the bottom. Sometimes people want to subtract just within a point, -3 minus 1 instead of -3 minus that one. The problem is if you do -3 minus 1 here, then you do 1 minus 5 over there, and it's all wrong. So remember, the y's are on the top, x's are on the bottom. You have to subtract in the same order. So it doesn't matter which point you start with, as long as you start with it for both the top and the bottom for the subtraction. So since I did -3 minus 1 on the top, I then also had to do 1 minus 5 on the bottom. I can't switch the order there. If I do, I actually get the opposite of the answer that I'm supposed to get, which makes grading really easy. Whenever somebody gives me a problem and they've got the opposite of the right answer, I know exactly what happened. But it unfortunately doesn't make it right. So watch out for that. And then number 3, be really, really careful with your negative signs. They are problematic. They like to fly off the page and just disappear. So please be really, really careful. All right, so I do have this example here, 5, 1, and 1, negative 3. So I did my subtraction, negative 3 minus 1, and then 1 minus 5. On the top, negative 3 minus 1 is a negative 4. And on the bottom, it's also a negative 4, giving me a slope then of 1. All right, so here's one more, well, I've got a couple more things. Let's do 2 more quick examples of finding a slope. And then I have one more thing I just want to look at real quick. All right, so I have 2 more examples here and on just finding a slope, and then we're going to look at one more thing. So first, I have the ordered pairs 2, 4, and 2, negative 6. Now, when I do my subtraction, I do negative 6 minus 4, which gives me negative 10. And then on the bottom, I do 2 minus 2, but 2 minus 2 is 0. This is a good place to point out and remind everybody that you cannot divide by 0. It doesn't work. It's not possible. So you can't say here that the slope is 0 because it's not. The slope is actually what's called undefined. It does not exist. There is no definition for dividing by 0. This is a vertical line. Okay? And so vertical lines are always going to have a slope that is undefined because their x-coordinates are the same. Now my second example, this time you'll notice that my y-coordinates match. They're both 7. When I do the subtraction, 7 minus 7 gives me 0. Then on the bottom, negative 1 minus 3 is a negative 4. This time we do get 0. 0 divided by anything is 0. This is a horizontal line, completely flat. So if you remember back in the last section when we looked at graphing, or a couple sections ago when we looked at graphing lines, we had vertical and horizontal lines. These are those 2 examples. All right, one more thing to look at real quick, and then we'll be all set. All right, the last example that I want to do is this problem. Graph the line passing through the point 1, negative 2 with a slope of negative 2/3. So this is a kind of an interesting little problem, and it's going to turn out to be really handy here pretty quick, like in the next section that we cover. But basically, here's what we do. We start at the point that we have. I gave us the point 1, negative 2, so here's 1, negative 2 right there. And then because we have this slope, we can use it, in this case, as basically directions to another point. So since my slope is a negative 2/3, I go down 2 and right 3. Now be careful. I go down, but I still have to go right so that I can get that line to be negative. If I went down and left, I would have a line with a positive slope, and we don't want that. So I go down through 2 and over 3. There's my second point, and now I have a line. And so this can be handy because in the next section we're going to look at what's called slope-intercept form. And that form for the equation of a line is going to give us the y-intercept, the place it crosses the y-axis. It's also going to give us the slope, which means it'll be a really easy way to just make graphs without actually having to go through the trouble of plugging in numbers. Anyway, that's something we'll see in the next section. So see you there.